Students, what's the next question of this particular chapter? Next question is what? State Faraday's laws of EMI. So, students, Faraday states two laws: first law and second law. Okay, what first law states? All of you concentrate, students. Whenever there is a change in flux, students, change in flux. Whenever there is a what? Change in flux. As I told you in the last lecture, maybe let me tell you. If I take magnet, okay, and if I take coil, if I take magnet, okay, having south and north pole, and if I take coil and if I attach galvanometer, okay, what will happen? If I move this magnet forward and backward, no, so magnetic flux associated with that particular magnet is cut by this number of turns, that coils, okay. And according to Faraday's law, first law, what states? Whenever there is a change in the magnetic flux associated with the coil, so remember, students, what is what induce? EMF is induced. So diagrammatically, I explain. If I take magnet, if I take coil, okay, if I keep this galvanometer or ammeter or voltmeter or definitely galvanometer, it is in series, no. So what we observe, there is some deflection. There is a what? Deflection. Okay, students. Let me explain, students. First you understand, and then I will just restart my Zoom application. So just understand, if I move this north and south pole of the magnet up forward and backward direction, so you will find some deflection. Students, if I keep magnet stable, students, there is a no deflection. There always be motion. Means what? There should be some movement of the magnet. Once magnet stop, there is a no change in flux. Okay. If there is a movement up forward and backward, up and down, whatever it is, there should be what? Some motion. There should be some uh, up and down or backward and forward direction motion. Then there is a change in flux. Then if there is a change in flux, EMF is induced. That is the first law. Understood? And one question asked by one student. Suppose students asking, sir, if I keep if I move this magnet very fast, if I move this magnet very fast, what will happen? Students, maximum EMF will induce. Remember that. If I move this magnet very slow, the small EMF is induced. If I move this magnet very fast, then EMF induced is what? More. Means EMF induced is directly proportional to what? Change in magnetic flux. That is the Faraday's second law. What is Faraday's second law states that? EMF induced is directly proportional to EMF induced is directly proportional to what? Change in flux through the coil. Remember this, students. What is the first law? First law states that if there is a change in flux, if there is a change in magnetic flux, EMF is induced into the coil. Second law states that EMF induced into the coil is directly proportional to the change in magnetic flux. Matlab what? If I move this magnet very fast, maximum EMF is what? Induced. Understood, student? This is a very important first law and second law. You can ratta this, but once you understand, if from the first, EMF is induced due to change in magnetic flux, and that EMF induced is directly proportional to the rate of change of magnetic flux. Remember this. Understood? Now Lenz's law, what Lenz's law states. Again, I took magnet. You can see. Now all of you concentrate. Now one question is asked from the student. एक student पूछता है, sir, if I move this magnet towards the coil, and if I move this magnet away from the coil, is direction of current will change? Yes, definitely will change. Understood the question, huh? Students? What is the question? Question was like this: if I move this magnet towards the coil, and if I move this magnet away from the coil, is there is change in current? I will tell you, or I will explain you. Yes, there is a change in current direction. That is called Lenz's law. What is the statement of Lenz's law? Lenz's law states that, students, all of you concentrate. When magnet is what moving towards the coil, Mean north pole is what? Moving towards the students. Direction of the current will be what? In anti-clockwise direction. Students are asking how you understand, sir, if the direction of current is anti-clockwise, because north pole is moving towards na. So remember this north pole ka, what is north pole ka symbol? N na. So this is what? Hint. N. What N they represent? When N pole is what? Moving towards the coil, direction of the current is what? Anti-clockwise. And when end pole is what? Moving away from the coil, then direction of current is will be what? With respect to S. So S ka direction dekho, it will be what? Clockwise. Understood, students? So what Lenz's law states that? Lenz's law states that you can see when motion is like this, current will be like this. It opposes. When motion is what? Away from, it opposes. मतलब opposite direction. Means what Lenz's law states that? Sorry. Direction of the what? Induced EMF or current in the coil is such as to oppose the change in the magnetic flux. Remember this point. Huh? What Lenz's law states that the direction of the induced EMF or current in the coil is such as to oppose the change in the magnetic flux. Okay, and what is the formula of E? E is what? D phi by dt. Now according to Faraday's law, d phi by dt, but it opposes, na? That's why it is minus. So students, what Lenz's law states that E is what? Minus d phi by dt. Remember this formula. Okay, E is what? Minus d phi by dt. Why minus? Because according to Lenz's law, whenever EMF or current is induced due to what? Movement of the magnet, then it opposes the change in magnetic flux. Hope so you understood the Faraday's first law, second law, and Lenz's law.